This module will cover Ohm's Law Part 2, and the math skills we will focus on will include division of whole and decimal numbers. Now let's take a look at an example. Our first example is 106 divided by 28.4 equals x. To accomplish this, much like with the multiplication examples, we're going to go ahead and encourage you to use your calculator. Just make sure that you're putting your decimal points in the correct places. 106 divided by 28.4 is 3.73. Notice in this instance it was a large number divided by a smaller number. That gave us an answer over 1. Let's take a look at a different type of example. In the second example, we have a small number divided by a larger one. 4.3 divided by 15.8. Go ahead and take a second to pause the video and calculate out your answer. 4.3 divided by 15.8 equals 0.27. So in instances where we have a smaller number divided by a larger one, we'll expect our answer to be somewhere between 0 and 1. Like with the multiplication examples, this lesson will cover Ohm's law. As a reminder, Ohm's law is derived from the mathematical relationship between three electrical conditions: voltage, amperage, and resistance. If two of these values are known, then the third value can be calculated using Ohm's law. Voltage is the electrical potential as measured between the positive pole and negative pole of a power source, while amperage is the number of electrons flowing past a certain point over a certain period of time. Resistance, on the other hand, is the opposition to current flow. To calculate amperage, we can use the formula voltage divided by resistance. To calculate resistance, we can similarly use the formula voltage divided by amperage. Let's look at how we use these in some real-world examples. In our first example, a technician is using a multimeter to make electrical measurements. The resistance of a taillight bulb is 3.3 ohms, and the voltage is 14.6 volts. Calculate the amperage of this circuit. Round to the nearest hundredth. To begin, we know that amperage equals voltage divided by resistance. We can take the values from the problem and plug them into our formula to calculate the amperage. We'll represent amperage with X since it's unknown. X equals 14.6 volts divided by 3.3 ohms of resistance. Thus, X equals 4.42 amps. In our second example, a technician is using a multimeter to make electrical measurements. The amperage of a speaker is 12.5 amps, and the voltage is 32 volts. Like with all Ohm's law problems, the first step is going to be finding the appropriate formula to solve for the value you're looking for. In this case, because we're looking to solve for resistance, we'll use the formula resistance equals voltage divided by amperage. Because we don't know what resistance is, we'll represent it with X. Thus, X equals 32 volts divided by 12.5 amps. Based on our calculations, we can say the taillight bulb circuit has a resistance of 2.56 ohms. Now that we've done a few examples together, let's take a few opportunities for you to practice on your own. Make sure to complete all the problems at the end of this module.